Need to look at some new functions now, and there's going to be quite a few formulas. So instead of writing those all out on paper, I'm just going to jump into the book and go through them with you. We need to look at something, a family of functions called the hyperbolic trig functions. And your trig functions, your original trig functions, they are related to or connected with a circle, in particular, the unit circle. And the hyperbolic trig functions, as the name would imply, are going to be attached to or connected more to a hyperbola than a circle. All right, so your hyperbolic trig functions, here are your definitions. First of all, the hyperbolic sine is e to the x minus e to the negative x over 2. The hyperbolic cosine is e to the x plus e to the negative x over 2. And what you're going to find is that these things are going to closely, but not exactly, mimic your other trig identities. For example, your hyperbolic tangent is hyperbolic sine over hyperbolic cosine. That should sound familiar. If you want to know what that looked like, you would simply take the definition of sine as given, the definition of cosine as given, reciprocate, multiply, do just a little bit of simplification. And you'll find that your hyperbolic tan is also equal to e to the x minus e to the negative x over e to the x plus e to the negative x. And again, the rest of these should look familiar. Cotangent is reciprocal of tan, secant reciprocal of cosine, hyperbolic cosecant reciprocal of hyperbolic sine. Again, these should look familiar because they pretty much, in an identical fashion, mimic what's going on with your other trig functions, with your standard trig functions. Now, if we move to the next page, they're going to show you some identities. Again, some of these are identical to their standard trig function counterparts. Some of these have a difference here or there, and you're going to want to pay attention to that. For example, sine is an odd function, and hyperbolic sine is as well. Cosine's even, so is hyperbolic cosine. Your first Pythagorean here, you'll see a difference, and this is something that happens on a regular basis. We know that sine squared plus cosine squared equals 1, but with the hyperbolics, hyperbolic cosine squared minus hyperbolic sine squared is what equals 1. We have another Pythagorean here. Again, you'll notice some things are the same and some things differ when you move from your standard trig functions to your hyperbolics. Your hyperbolic sine, for example, if you were to remove the h's, that identity would be identical. With the cosine, if you remove the h's, there's a minus difference that's supposed to be here. This plus should be a minus if this was a standard cosine, but with the hyperbolic cosine, the plus is a plus. All right. So again, knowing your standard trig identities might help you memorize these, but they're not all identical. You will have to be able to remember the differences. The derivatives of the hyperbolic trig functions, the best way to do those, without doubt, is to use the definition. They show this above here. The derivative of a hyperbolic sine is the derivative of e to the x minus e to the negative x over 2. And the 2 here, since it's just a constant, can be basically just thrown into your answer as I've done here. Derivative of e to the x is e to the x. Derivative of e to the negative x brings out a negative sign, which cancels the one that was there. And that's how the sine turns into a cosine. Again, if this was a standard sine and a standard cosine, it would be the same. But when you go from there to cosine derivative turning into sine, you notice that there's a negative that you expected that was not there. Right? So again, most of these should look very familiar. They should look almost identical. It's just that at times there's a negative there that you didn't expect, or a negative missing that you did. Right? So again, this is just going to be a separate batch of derivatives you will have to memorize, unless you want to repeatedly have to go to this definition and derive these things again and again. That will be time consuming. So you really should lean towards simply memorizing these derivatives. Right? Next, we see that if you were to algebraically solve for hyperbolic sines inverse and hyperbolic cosines inverse, you end up with logarithms. Again, that can be done. If you take your hyperbolic sine of x and set it equal to y, and then exchange the x and the y, which is the standard procedure for solving, all right? And then take the sine of both sides, and from there, you're going to do some fairly complicated algebra and solve for that brand new y. You'll see that that's what you get. Right? These expressions are simply found by algebraically solving for the inverse. And once you have those definitions, once you have these definitions in hand, the derivatives are found by simply deriving these or taking these derivatives as they are written and doing quite a bit or considerable amount of algebraic simplification. Again, enough algebraic simplification, it is not worth it to have to do that every single time. I would definitely suggest you just memorize these derivatives as well. Yes, that's a lot to memorize, but that's sort of the nature of the game. And again, with these, notice that some of them look just like what you had with the sine, cosine, and tan, and with some there's a little bit of a difference. Again, like for an example, with this tangent, if there was a plus in there, it would be identical to the standard tan, but there's a minus instead. All right, so be aware of that, and be aware that the fastest, simplest, and best thing to do is simply memorize these definitions and use them as written.